Good morning, everyone. So our group will present about ECA, which is Elemental Cost Analysis, for our project school at Jalan Bitulumiri. So let me introduce myself. My name is Sunny Jackson Anasani. My other team member is Muhammad Khalid bin Yahya, Intan Zafidah binti Daud, Laura Natasha, and last but not least, Farisah binti Tarini. So today we're going to explain about what is SCA and the SCA that we will propose for our project.
Hi, my name is Laura Natasha, and today I'll be discussing about ECA. What is ECA? ECA is called as elemental cost analysis. Is a method used to estimate construction costs by examining the expenses of similar buildings that have already been completed. It allows for more accurate cost prediction for future projects. So this method plays significant role in designing future building project by providing valuable information. So it helps us make early cost projection and determine the essential cost component for similar future project. To build an accurate elemental cost analysis, a few key components are necessary. So the first one, we need a BQ, which outline the number and specific of each work item required. Then building plan, including elevation, design, are used to understand the project scope. So the BQ and the building plans give us a detailed picture of the project needs. These elements form the foundation for an accurate cost estimate, ensuring that future projections are grounded in real-world data. ECA also estimates are based on contractor's proposal and not actual costs. Estimate often differs from the final cost due to scope change or unforeseen issue. So Woon and Moy 2010 highlight the difficulty of matching the initial bid with the actual cost. Further important in budgeting, ECA is critical for budgeting similar projects like size, location, and type. It provides reference data for the future, more accurate cost estimate. Also, it helps prevent the underestimation of cost and facilities financial planning. This project involved building a new school in Bintulu, Sarawak with 36 classrooms, dorm for 450 students, and 24 teachers' quarters. It is located near major road. It ensures easy access for students, teachers, and staff. The project will also include supporting facilities like canteen, sport facility, and multi-purpose hall to enhance the learning and living experience. The site is along the Bintulu Road, offering convenience access. However, being in a rural area, it may face logistical challenges, such as metro delivery and skill level availability. The land shape may complicated early construction stage, but the contractor is expected to manage this effectively. The main objective is to build a modern school that meets both academic and residential needs. The designs include 36 classrooms with modern teaching aids, 450 student dorm, 24 teachers housing unit, and facility like a canteen, sport amenities, and multi-purpose hall to support learning and social activity. The client is government agency adhering to guidelines from the Ministry of Education. The project aims to improve public education with modern facility. The Public Work Department JKR manage the tendering process, ensuring fairness and transparency. A design and bid contract has been chosen, allowing the contractor to handle both design and construction. This approach ensures smooth coordination. JKR oversees the tendering process, evaluating bids to ensure the contractor has the required experience, resources, and offers fair pricing.
Good morning, everyone. So my name is Sunny Jackson Anasani. So today I will present an elemental cost analysis or ACA for government construction project in Bintulu, Sarawak. So before we start, what is ACA? ACA is elemental cost analysis is used to break down and analyze the total of construction cost of the project by individual element of components such as substructure, superstructure, finishers, and services, and so on. This allows the cost planner, clients, and the contractor to understand where is the money being spent and help the budgeting, benchmarking, and cost control. Firstly, is a project overview, which is cadangan pembinaan sekolah menengah baharu 36 bilik darjah, 460 pelajar asrama dan 24 unit rumah guru. So, there we start with Form 1. Form 1 is involved as a new secondary school block, staff facilities for 460 students, 24 units of teacher quarters, and plus multipurpose hall. This project is located at Bintulu Sarawak, surrounded by the tree and natural obstacle access in the via Jalan Bintulu Miri. The client for this project is government and the tender date was 3 February 2022. This project used PWD Form 203A version 10/83 with the quantity. There is no cost participation clause. It's a government funded award through the negotiation. Here are the cost component. First is prime cost sum, which is 477,092 ringgit. For PV sum is 96,989 ringgit and 85 cents. Preliminaries consist about 138,246,000.63, about 4% of the project. The contract sum total is 2,487,024 ringgit and 92 cents. The cost of the afterworld all element is 3 million. The building is single-story rectangular structure with multi-purpose hall in the center, walkway on site, separate toilet for men and women, and special ramp for disabled use. Functional of unit of this project is 1,800 meters square. Gross floor area is 719 meters square. External wall area is 762 meters square. Roof area is 1.2K meter square, and the closed floor space is 396.23 meter square, and story height of the ground is 6.8 meter. This SCA for the summary is finding the best single-story educational building. It's highlight all the cost element involved for the structure to the services. The functional of unit cost excluding external work is 3,139 ringgit 41 cents per meter square. This design made the educational and accessibility standard with proper circulation and user included. In conclusion, essay giving a detailed breakdown of the way the project is allocated, helping planner ensure the design stay within the budget while the meeting all the functional and regulatory requirement. Thank you.
Hi everyone, my name is Intan Zafida binti Daud. Today I will be explaining the Form 2. Form 2 is a cost summary sheet that presents the elemental breakdown of a construction project. Instead of showing the cost by trades like concrete or brickwork, it groups the cost based on function or building elements, for example piling, walls, finishes, electrical system, and external works. This makes it easier to understand where the money is being spent and to compare the cost between the different projects and to evaluate the design efficiency. Form 2 is typically used during tender evaluation, cost planning, or benchmarking in projects, especially for large buildings like schools, offices, or hospitals. Hi everyone, my name is Intan Zafida binti Daud. Today I will be explaining the Form 2. Form 2 is a cost summary sheet that presents the elemental breakdown of a construction project. Instead of showing the cost by trades like concrete or brickwork, it groups the cost based on function or building elements, for example piling, walls, finishes, electrical system, and external works. This makes it easier to understand where the money is being spent and to compare the cost between the different projects and to evaluate the design efficiency. Form 2 is typically used during tender evaluation, cost planning, or benchmarking in projects, especially for large buildings like schools, offices, or hospitals. Now let me explain how the form is structured. At the top, we can see the gross floor area of the building, which 719 meter square. Then the elements are grouped into sections like substructure, superstructure, finishes, fittings and furnishings, services, external works, and preliminaries. Each rows shows the total cost of the element and the cost per meter square in a meter, and the elemental quantity, usually the floor area, and even details like reinforced concrete volume, formwork area, and reinforcement weight. This allows for detailed analysis at both the summary and technical level.
Greetings, my name is Farisa binti Tarini. My student ID is 2024256736. Today, I will briefly explain how elemental cost analysis or ECF form for Form 3 that relates to our selected project, which is the construction of a new secondary school in Bintulu, Sarawak. This project involved building 36 classroom dormitories for 450 students, 24 units of teacher housing, and other essential facilities such as multipurpose hall, canteen, and sport areas. The ACF form breaks down the project cost into 6 elements that match exactly with the scope of our project. First, the substructure and superstructure cover all structural work including piling, foundation, reinforced concrete frame, floor, roof, wall and stairs. These are necessary to create the main building framework for the classroom, dormitory and other blocks. Second, finishes refer to the all interior and exterior finishing work such as plastering, sealing, painting, sealing, and waterproofing. These finishes make the space functional and also suitable for learning and living. Third, fitting and furnishing included the installation of sanitary appliances like toilets, basin, bidets, which are important for student and staff facility. Services involved in the mechanical and electrical systems such as plumbing, electrical wiring, lighting, ventilation, and fire protection. This system ensures safety, comfort, and compliance with the building regulation. Fifth is the external work, cover the site preparation, drainage, road, car park, and the connection of utility. Since our project is in the rural location with limited access, these work are essential to support the overall development. Finally, the ECF form help us benchmark our cost against the similar school project to ensure that our budget is competitive and realistic. Thank you.
Assalamualaikum and a very good morning to Sefais. My name is Muhammad Khalid Yahya. So I will present about introduction of cost benchmark. What is benchmarking? So cost benchmarking is a simple terms that have been used in construction economics to comparing our project with the others project. But the comparable project must be same categories with the project that we want to build. So why cost benchmarking matters? It By doing cost benchmarking, it can help us to answer several key questions for our project, which is this project is cost efficient, and where can we save money, and we also can getting good value for what we spend. So cost benchmark have been used in many stages such as planning, budget setting, and procurement of material or services. According to the Royal Institution of Chartered Surveyors (RICS 2021), successful benchmarking needs several items like up-to-date cost data, adjustment for location, inflation and project size, and a reliable of cost database. In Malaysia, we have tools like the CIDB cost model. These tools make benchmarking easier and more consistent. They also promote transparency and accountability, especially important in both public and private sector properties. So this is the bar chart of benchmark analysis for Project School at Selangor. Our group get it from the BCSM to 2024. The reason why we choose project school because our case study project is also project school. So this is the bar chart for our case study project at Bintulu, Sarawak. For the project detail is RM, the cost is RM 3,199,353 and 40 cents. For the GFA, 790 meters square. So for the updated mean price, how we get it? So we just take take the take all the amount from the previous project, which is at project school at Selangor, like I have shown before this. So we just need to convert the amount into the location index at Bintulu. So the total updated mean at Bintulu is RM 3,744. For the benchmark project amount, we just take it from the form 2 at the elemental cost analysis. And for the difference, how we get it is just a benchmark project minus updated mean and divided with updated mean and times 100. So that is the formula that how we calculate to find the difference between updated mean price and benchmark project. So from from all these elements, substructure is the most highest difference, which is 38%. And it showed that benchmark project costs less than the mean price by 722 per meter square because total updated mean price minus with total benchmark project, which is RM 3744 minus with RM 3022, and we will get RM 722. So the element showing that the largest cost difference is substructure, which is 38% lower than mean price. To sum up, ECA is a method used to analyze and break down the total cost of a construction project into its major building elements like substructure, superstructure, finishes, and so on. It's one of the most widely used methods for estimating and reviewing costs across different stages of project. Why we need to use ECA? The purpose of the first thing first, we need to understand the purpose of ECA, which is ECA can help us to understand how cost is distributed across the building. ECA also can help us to compare actual costs with the initial forecast during the tender stage and support accurate budgeting and future cost planning. ECA also very useful for quantity surveyors like us because it can help us to helps client for estimating the cost of similar future projects and do a benchmarking design for structures against previous builds and making informed decisions about budgeting and procurement. So by use the tools, we can estimate is it the project can give a benefit to the client or not. So that's all from our group. Thank you.